Dear students, you are welcome. Good afternoon to all of you. And now we are going to discuss relationship between nutrient supply and crop growth. So I welcome you again in this class. And now we are going to discuss relationship between nutrient supply and crop growth. So it has been a matter of research by different scientists for a long time. Once the essentiality of nutrients was established by scientists, then they started knowing that how much nutrient should be supplied to get the best growth. What should be the quantity of nutrient? So number of scientists made attempt to exactly establish the relationship between nutrient supply or amount of nutrient supply to the growth. So that we are going to discuss in detail, and it is mostly historical, and some are even relevant today also. So after completion of this lecture, you will be able to learn the relationship between nutrient supply and plant growth. Understand the quantitative changes in crop growth in response to application of nutrient. If you apply X quantity of nutrient, how much is the change in the Y? That is your biomass or growth or yield of the plant. So such kind of relationship we are going to see. Some difficult words or some terminology related to it. Alluviation, the removal of soil material in suspension or in solution from a layer or layers of a soil. Foliar diagnosis, an estimation of mineral nutrient deficiencies or excesses, maybe toxicities of plant based on examination of the chemical composition of selected, means you are going to have plant analysis. Fraction, what is fraction? A portion of a larger store of a substance operationally defined by a particular analysis or separation method. Hidden hunger, I discussed already. Linear response, when the physical output goes on changing proportionately along with input, the response is said to be linear. Y is equal to A plus Bx. Side dressing is kind of the application of fertilizer alongside row crop. So it is kind of top dressing, but top dressing in controlled manner. You just apply in bands near the crown part of the stem. Optimum economic dose is the rate of fertilizer application where you get maximum return and minimum pollution of the environment. Arid climate, climate in regions that lack sufficient moisture for crop production without irrigation. Soil amendment, any substance other than fertilizer such as lime, sulfur, gypsum, sawdust used to alter the physical or chemical properties of a soil, generally to make it more productive. Edaphology, the science that deals with the influence of soils on living things, particularly plants. Now we come to the growth. What is growth? I have already explained you in another course. What do we mean by growth? So a permanent increase in size with dry weight is your growth. The optimum growth of the crop gives generally higher yields with optimum use of growth factors. Income of the farmers can be enhanced by combining the optimum level of inputs and growth factors. So there are a number of growth factors and their combinations, and also in the nutrients. In nutrients also you have got number of nutrients and their combinations. So you can see more than 100 if you convert these nutrients, every nutrient into a factor, then you will have many more factors that affect the growth of the plant. So this kind of chart I have already shown you in another course, but it is just a refreshment, refreshing, not refreshment, refreshing your memories. Factors like external factors, genetic factors. External factors are three: environmental, management, and socioeconomic. In environmental factors, you have abiotic, biotic. In abiotic factor, you have water, atmosphere or air, nutrients. Nutrients are a factor, abiotic factor, and temperature and your soil plus light. So these are abiotic factors. So you can see that nutrients are going to affect the growth. And they have very good interaction with other factors. Like nutrient has very good interaction with your water, and they have very positive interaction most of the time. And then you can have interaction of nutrients with light also. Can you tell me how you can have interaction of nutrients with light? Means nutrients are there in the soil and light is there in the sky or in the environment and coming to earth. So how this light and nutrient in soil can interact? Anybody has got any idea? It is not in books. It has come to from your brain. It is not in books, dear students. It has come from your thinking, how you can think over it, how light can influence your nutrients. It's so simple. It's so simple. They are affecting the plant. They are affecting the plant, and plant can affect the soil. They are influencing light is influencing the growth of the plant. If you get optimum light, sufficient light, good quality light, then growth of plant will be good. Better growth of the plant means it will improve the soil growth better compared to other soil health better. It will help. In one course, I taught you effect of plants on soil. You remember? Effect of plants on soil. So this, suppose if you get abundant light, more photosynthesis is there. So it will result in increased diameter in the plant. Increased diameter in the plant means more root exudates. More root exudates means more microbial activity, more root growth. So ultimately your soil will get some nutrients from the plant back and it can improve microbial. So this is how we can relate the thing. Anyway, we move forward. Now, nutrient supply as a factor of crop growth. A great deal of factors affecting the crop growth. Under abiotic factors, availability of nutrient is listed as an important factor that affect the growth. So thus, adequate supply of nutrient is necessary. But what should be the quantity of the nutrient? What exact quantity I should supply to the soil or to the plant? That how can I know? So people made several attempts. So one attempt was that critical concentration of nutrient. This is already discussed with you. Crop growth response to nutrients. So what can be done? Nutrient deficiencies, toxicity in soil crops are usually identified by chemical analysis. Just we have seen. Better is by evaluating crop responses to applied nutrient. So crop responses to applied nutrient. You can take different fertility grades and can know the response of a particular nutrient in a particular climatic and soil conditions. And then you can give recommendation. Means it is simply by trials, field trials. If crop responds to applied nutrients in soil, this suggests that nutrient is deficient. Relative decline in crop yield in the absence of a nutrient can give idea of the level of nutrient deficiency. Then we can know if the level of nutrient we want to decide, then it can be related to relative deficiency of that nutrient in the plant. Now this is what I wanted to teach you now in this lecture. I just made a background, a story to come to this Liebig's law and law of diminishing return. So actually law of declining yield improvement. Actually students have studied this law in agrobiology. Agrobiology, I don't know whether it was taught to you in principles of crop production. You studied principles of crop production?
Yes, sir.
So did someone teach you about this agrobiology? Wilcox agrobiology? And
yes, sir. Wilcox agrobiology.
Okay. So then some of these must have been covered, particularly this law of declining yield improvement. It was given by Mitscherlich, you know, Mitscherlich. So Mitscherlich was the main person behind agrobiology. In fact, this Wilcox was fundamentally inspired by Mitscherlich. So basic work was done by Mitscherlich, and Wilcox just manipulated the things and wrote plus minus things. But it was mainly this Mitscherlich who was founder of the agrobiology. Anyway, now these are important in this crop growth response to nutrient. Knowing the relationship between nutrient supply and crop growth. Relationship between nutrient supply and crop growth. So Liebig's law of minimum is one. It also relates to nutrient supply to the plant growth. Law of declining yield improvement, it is by Mitscherlich. Spillman's equation, Baule concept, and then comes the curvilinear models. These are modern day approaches. Modern day approaches to decide the supply of nutrient or relationship between supply and growth. And then nutrient use efficiencies are the most frequently used things now. That if you have 1 kg nitrogen, how much is the change in the yield? So these nutrient use efficiencies are also important tools in telling us the response of nutrients to the growth or yield. So if I say growth here, it also includes yield. The meaning also includes yield, growth and yield. So plant yield is primarily dependent on the factor that is most in the minimum. So it was said by Liebig's law of minimum. Now you can call it Liebig law of minimum. Sprengel, you remember 1828. Then later the law was inferred that this is single factor decides the production. So it has got several interpretation actually. So Liebig's law of minimum was written in German language, and you cannot translate everything in the exact sense. So people have translated it differently also. Therefore, you will find different definitions of this Liebig's law of minimum. So ultimately, it was inferred that this single factor decides the production, means the single factor which is present in the minimum. So it can be extended to other factors also, like, you know, Blackman, he proposed law of limiting factors perhaps in 1905. So he just copied the idea of Liebig and put it in different perspective. He has taken all the growth factors, carbon dioxide, temperature, and so on, influencing photosynthesis, etc. Only the context was changed. The fundamental principle remains same. If you supply any of the growth factor which is present in least quantity, will decide the use or will decide the growth of the plant. So plant yield is primarily dependent on the factor that is most in the minimum. It was told by Liebig. Later, the law was inferred that the single factor decides the production. Yield increases in linear fashion. An increase in this factor is still some other factor which is now a short supply. Means if you overcome the factor which was present in minimum quantity, if you overcome that, if you add that, if you remove that, then yield will again start increasing linearly. And then another factor will become limited. You overcome that, then again the yield will increase linearly. So this is how you can understand the Liebig's law of minimum. So this is the case from Havlin book. I taken this example. So you can see here how they are interacting, how different factors are interacting. So nitrogen from left to right, it is increasing. This is nitrogen input. This is the increasing quantity of nitrogen in soil. And then suppose there were only 3 limiting factors. Initially, there were 3 limiting factors. There was not enough moisture in the soil. Phosphorus levels were low and seeding rate was low. So there were 3 factors which were limiting initially. Suppose you have overcome. When these 3 factors was limiting, you were getting the yield up to the level of A. This much of growth was there. But if you overcome just one factor which of the limiting factor, say water, you applied the water, then nitrogen use improved. Then only 2 factors remained limiting. So one was overcome. So because of this one factor, when you overcome the one limiting factor, then there is change. So this change is because of this factor, water, because of water, this much of change is there. So other is also responding. This nitrogen is also responding to this. And then you remove the phosphorus deficiency also. Then again, there will be change. So this is because of phosphorus addition. And you also know the quantity. So it is easy to develop relations. And then ultimately, even you remove the seeding rate also. These are very hypothetical example. Do not go into agronomic meaning of these, because at this stage, seeding rate cannot be met. These are very hypothetical things. Just treat them as three limiting factors. Three different limiting factor here, then two, then one, then no. So no limiting factor is D, means you cannot get in any case more than this yield. So this is your highest yield. This is maximum possible yield when all the factors are present at the maximum level or at the best level. So you can go through this slide also, I will share. So then law of declining yield improvement. This Mitscherlich studied the law of minimum and he criticized it. He pointed out the mistakes in that law. So Mitscherlich proposed two laws in relation to growth, yield and supply of growth factors. Here he gives it growth factors. So Mitscherlich's law of physiological proportion, this is number one. And number two law is Mitscherlich's growth law. He proposed two different laws. Yield can be increased by each single growth factor, even when it is not present in the minimum. Even when it is not present in the minimum, as long as it is not present in the optimum. So actually, he said yield can be increased when you increase the level of nutrient beyond the minimum, and there must be some limit beyond which you cannot increase the yield, and that limit is optimum level. So he talked about optimum level. However, Liebig did not talk about optimum level. He said you go on increasing the level of one input and also other yield will increase linearly. Then Mitscherlich's growth law. Increase in yield of a crop as a result of increasing a single growth factor is proportional to the decrement from the maximum yield obtainable by increasing the particular growth factor. So it is very easy to understand this growth law. It is basically based upon your law of diminishing return. Law of diminishing return means initially the growth will improve as you improve or increase the growth factor. The input, the level of growth factor is, the quantity of growth factor is increased, the yield will increase. But after a certain point, the increase in yield will decline. There will be decrement in the increase. So initially you can get 1 unit, next time you can get 0.8 unit change in Y due to unit change in X. So likewise, this is decrement, the amount of decrease or gradual decrease in quantity, or gradual decrease in marginal return, you can say, or marginal product, MP. Mitscherlich discarded Liebig's assumption that yield increase produced by fertilization was directly proportional to the quantity of nutrients supplied. Means if you supply more, you will get more yield, that limited nutrient. Plant growth increased as more of this nutrient was added, but not in direct proportion to the amount. The increase in growth with each successive addition of the element in question was progressively smaller. Simply law of diminishing return. Mitscherlich concept is expressed mathematically as dy dx is equal to a minus v into c. So where dy dx is the rate of increase in yield, the change in yield due to unit change in x, y produced by addition of a deficient nutrient x. X is the level of nutrient. A is the maximum possible yield obtained by supplying all growth factors in optimum amounts. Y, capital Y, this one. is the yield obtained after any given quantity of the factor has been applied. And C is the proportionality constant or efficiency coefficient or factor. So this is how this Mitscherlich equation is there. If you want to learn more in more detail, I sent you one book, Soil Fertility Evaluation and Control by C.A. Black. This book contains a chapter or two chapters on this aspect under agrobiology. So you must read that few pages from that book if you want to gain knowledge, detailed knowledge in this subject. Then came Spillman's equation. Now nobody likes it and it has no relevance. But one thing I want to tell you that Mitscherlich equation is all even used today to decide the optimum quantity of fertilizer. When I was a student, our teacher used to teach us calculating the optimum dose of fertilizer through Mitscherlich equation. Even today, if you open research journals that are related to soil fertility and fertilizers, and you type in search Mitscherlich equation, you will find many recent papers. They are based on Mitscherlich equation. So Mitscherlich equation is relevant even today also. So many people are doing research, taking help from the Mitscherlich equation, but in different areas, they are using it. Similarly, but Spillman's work is not being used by people. It is just in history. In 1924, Spillman edited a book dealing with the law of diminishing return and its relation to biological production relationship. He developed a mathematical expression of crop yield response to plant nutrients. This was the kind of relationship established by him. Y is equal to m minus AR power x. This was basically based on Mitscherlich equation, or sometimes it is called as Mitscherlich yield equation, where Y is yield expected from X amount of applied nutrient, M is theoretical maximum yield possible, A is theoretical maximum increase in yield obtained by increasing X, R is constant. So then comes the Baule concept. You already studied Baule concept, so I will not give much thrust on this. He proposed modification of Mitscherlich law of physiological relationship. Means he said that every time there is 50% reduction in output. So suppose one unit increases 100% maximum, and then next unit will increase 50%, then 50% of the previous 50, something like this. So this is not much important. But anyhow, you can see introduce the concept of effect quantity H, which is the quantity of the nutrient necessary to produce half or 50% the maximum yield. This quantity is known as Baule unit. One Baule unit will increase yield by 50% of the maximum. Two Baule units, 75% of the maximum. And you go on by 9th or 10th unit, you can go up to 100%. So this is just a fantasy. And in fantasy, he has calculated this value of C 0.301. You can go through it. The other important thing is curvilinear or non-linear models. These are modern day scientists and students are using it. I have already told you this in principles of crop production. Is it true? Did I teach you this curvilinear relationship models, optimum dose of fertilizer in crop production? Principles of crop production. Is there any single person present?
Yes, sir.
Okay.
Yes, sir.
Very nice. So did I teach you this curvilinear models or optimum dose of fertilizer in principles of crop production?
Yes, sir.
Yes, sir. So no problem. So you understand, means overall you can see these models are based on law of diminishing return where quadratic, square root, logarithmic, Mitscherlich equations are fitted. So the Mitscherlich equation itself is a kind of curvilinear model. It is quite common in biological organism, curvilinear kind of relationship, initially very slow, then increases at very fast, then slow rate, then becomes negative. So these kind of relationships are quite common even in organism, biological organism, and in plant also. The pattern of plant growth over time starts slowly, increases to a fast rate at immediate growth stages and slows down. Optimum dose you can decide through quadratic relationship. So these models are already there. So I'm not going into the details, but I want to go into the little details about nutrient use efficiencies. So they are also important. Through them, we can know the growth level or the yield level. How much is the change in dry matter? Even nutrient use efficiency, we can calculate in terms of biomass or dry matter also, or economic yield also. It depends upon the interest of the researcher. Many times students get confused that this efficiency, for example, physiological efficiency, should I calculate it based upon the seed or the uptake in seed or in biomass or in straw? So it depends. You can define it that this is for straw, this is for grain, and this is for biomass, total biomass. If you define that this physiological efficiency has been computed or calculated for straw or for grain or for total, then there is no problem. So we need to know certain formula of nutrient use efficiencies, and they very well represent the response to nutrients. Suppose if I use 1 kg zinc, how much is the change in the nutrient use efficiency? Zinc, 1 kg zinc, how much is the increase in yield? If I add 0.5 kg zinc, how much is the change in the yield over control? So this is also telling us relationship between nutrient supply and the plant growth or plant yield. Is it correct or not? This nutrient use efficiency, can we consider them as the relationship between nutrient supply and plant growth? Am I doing it in right direction or wrong direction?
Yes, sir.
Yes, sir.
So because
Yes, sir.
Right, sir.
in books you will not find force. I'm not forcing you, but I tell you, when you see the subject of nutrient supply and plant growth, first thing is that you will not be able to find out answer or any content in any book. So we need to collect the things from here and there. Sometimes we need to collect the things from here and there and make a capsule, make a package. So to make this package, nowhere you will find nutrient supply and plant growth in a systematic way. If you find, please share with me. So what we can do, we can assemble the things. So I just assembled the things here. So this is also assembled part, nutrient use efficiency and plant growth. So now I am sure that this is placed at a right place. So nutrient use efficiency is the maximum economic yield. So how to define it? Is the maximum economic yield produced per unit of nutrient applied, absorbed, or utilized. Remember, it is applied. It can be based upon the application rate, or it can be based upon absorption rate, or utilization rate by the plant to produce grain and store it. It is useful for to differentiate plant species, genotypes, and cultivars for their ability to absorb, utilize nutrients. So we must know that which varieties of which plants or which species or which kind of crop is more efficient for a particular or efficient user for a particular nutrient. And these days, people have gone to the gene level. I think you must be knowing that nutrient use efficiency is now being dealt by the biotechnologists at the gene level or molecular level. I'm not expert in that area. Now people are researching QTL, certain QTLs. I don't know what is QTL. They are doing research at QTL level, and now this subject has entered fully the genetics or biotechnology subject. So now it is in the area of, so if you want to nutrient use efficiency, they are dealing at gene level. But okay, we are agronomists, we deal at plant level or biomass level, not at gene level. So useful to differentiate plant species, genotypes, and cultivars. Some of the commonly used efficiency definitions are given in the next page. I must have discussed at some other point of time also. Partial factor productivity of applied nitrogen. This is called as nitrogen use efficiency, or NU, kg harvested produce or product per kg of nitrogen applied. So this is how PFN can be calculated. Yield in the nitrogen applied plot divided by fertilizer rate or nitrogen rate. And it has relationship with AEN also. PFN is equal to Y0, Y0 yield at control, yield at control and divided by fertilizer nitrogen rate for this N. This N is same N here. And then plus agronomic efficiency. Agronomic efficiency, you can see what is agronomic. Kg yield increase. Dear students, remember, it is never kg yield. It is always kg yield increase. Kg yield increase per kg nitrogen applied. This is the unit of agronomic efficiency, and it can be calculated Yn, yield in nitrogen applied plot minus yield in control, divided by rate of nitrogen application. And AN is equal to RN into PN. So you can get the relationship. Then recovery efficiency is the percentage increase in uptake. So for percentage, you can multiply by 100. Uptake in nitrogen treated or applied plot minus uptake in control divided by N rate, kg per hectare. And then physiological efficiency is kg yield increase. If you are calculating it with respect to yield, kg yield increase per kg increase in N uptake. So yield in nitrogen applied plot minus yield in control divided by uptake in nitrogen applied plot minus uptake in control plot. So likewise, you can calculate the physiological efficiency. And in the sense of fertilizer, when we apply fertilizer, it is mostly recovery efficiency people see. What is the recovery of fertilizer? That is actually recovery efficiency of nitrogen. So here I have suppose given for nitrogen. It can be equated. It can be equal to other nutrient also. If you want to calculate for zinc, same formula can be used for zinc or phosphorus or any. You need to change this N only. And regarding physiological efficiency, this is for with respect to grain. And you can calculate it for the total biomass also. Total biomass also, you need to, in yield, you can put the dry matter or biomass and in the control, and similarly uptake in total uptake in biomass minus in the control treatment. So likewise, you can calculate this PFN. So overall, you have seen formula for this, and now higher nutrient use efficiency are desirable as these result in maximum economic return. If per kg nitrogen, we are getting 20 kg grain. If we get 30 kg grain, then it is fantastic because we are applying just 1 kg nitrogen. So if its efficiency is high, if we are able to increase the efficiency, then we will get more profit because our cost of 1 kg nitrogen will remain same. Nitrogen is 1 kg, and if you get more and more yield, then definitely it will be very economic also. So researchers try to increase the it is nutrient use efficiency. So we need to understand the factors that affect the nutrient use efficiency. So first is climate. Climate will affect the nutrient use efficiency because climate can have adverse temperature, adverse solar radiation, and precipitation or rainfall. High rainfall or too low rainfall can be harmful, can affect your nutrient use efficiency. So nutrient use efficiency can be affected by climate. It is your job. Today I give you homework. You just put your thinking how this climate can affect the nutrient use efficiency. If you understand the nutrient use efficiency, how we can increase the nutrient use efficiency simply by increasing the numerator and decreasing the denominator. So how we can decrease the denominator by better fertilizer management, how we can increase the numerator by better agronomic management. So this is how you can put the thinking, how this climate will affect the nutrient use efficiency. This temperature can directly affect the growth of the plant. It can directly reduce or increase or give better. So you need better temperature. So you need to think from that point of view also, that overall the crop growth biotic, even biotic, abiotic factors will become part of this. So climate is important, and strategies for enhancing variety selection. Certain varieties can tolerate temperature or water stresses. So we can go for variety selection. So this is your job to think and find answers. I'm giving you just hints. Adoption of efficient crop, soil, and nutrient management practices, how they can improve how they can overcome the climate-induced problems or climate-induced limitations. We need to see this. Then comes the soil-related issues. A soil which is more eroded and a soil which is not eroded, how the nutrient use efficiency will behave. Low soil fertility, deficiency, toxicity. So all soil-related constraints are there. Higher the constraint, and you can have lower nutrient use efficiency. Similarly, appropriate soil and water conservation measures. What are the strategies if you have soil as a constraint? Please do think over it. And if you think over it, you will summarize the whole fertility in these just 2-3 slides. How the crop can affect the nutrient use efficiency. Why a certain crop or cultivar will have low nutrient use efficiency. Cultivation of nutrient use inefficient cultivars is the reason. And you can find the solution and see the characteristics also. Similarly, fertilizer. This is, I told you, numerator and denominator. So your denominator now is fertilizer on nutrient application rate. So inefficient management, you don't know right time, method, and source, and so all these will come if you want to improve the nutrient use. So fertilizer related constraints. And finally, cultural practices. Your all agronomic practices like crop rotations will affect the nutrient use efficiency. So therefore, you can at least remember that factors like climatic factors, your soil factors, crop factors, climate, soil, crop factors, your fertilizer factors, and cultural practices. These 5 factors will affect the nutrient use efficiency, and a complete question can come sometimes in your life on this subject. Why nutrient use efficiency is low? How you can improve the nutrient use efficiency by managing the adverse climate, by managing the adverse soil, by getting the best crops, and by getting the best cultural practices, fertilizer practices. So this ends here. Thank you very much. I liked it. And now I just wish